Hello folks, Prasad Domla here. In this video, I'll show you how to analyze and visualize AWS VPC Flow Logs using Elastic Search and Kibana. So let's get started. First, a little bit of background on Elastic Stack. So Elastic Stack consists of mainly Elastic Search, Kibana, Logstash, and Beats. Elastic Search is considered as the core of Elastic Stack, which is a distributed RESTful search and analytics engine. We can basically ingest huge amount of data into Elasticsearch and derive interesting insights based on that data. The next component in Elastic Stack is Kibana, and it is basically your window into your Elasticsearch. So we can visualize and query your data ingested into Elasticsearch using Kibana, and it is a web-based dashboard where you can create visualizations and dashboards based on your data. Kibana has many inbuilt ways to visualize your data, including all types of graphical representations. You can use queries to extract exact data as you want, and it is highly customizable. Next component is Logstash, which is server-side data processing pipeline, which ingests data from various sources into Elasticsearch, and it basically transforms your data based on different formats or filters, and sends to Elasticsearch, where we can analyze that data. So the data sources can be your log files, S3 buckets, databases, REST APIs, Kinesis streams, Redis, and so on. So basically Logstash supports almost all kinds of data sources. So we won't be using Logstash in this demo, as we'll be ingesting data directly from AWS CloudWatch, where our VPC Flow Logs are stored. And next we have Beats, which is a lightweight data shipper, which is kind of an agent installed on the system where our data resides, and it will ship your data either to Logstash for processing or directly to Elasticsearch. Again, we won't be using it in our demo today. I'll show you Logstash and Beats in another video maybe for a different use case, but for this demo where we analyze VPC logs, we don't need Logstash or Beats. So that's a brief overview of Elastic Stack. This is a pictorial representation of what we'll be doing today. So we have a VPC on which we have enabled flow logs, and these flow logs will be pushed to AWS CloudWatch. And on CloudWatch log group, we'll create a subscription to a Lambda function, which will be automatically created when we create a subscription. And this Lambda function is responsible to send the logs to Elasticsearch. And we'll be using Kibana to view those logs and create our visualizations and dashboards. Now let me show you how to do this. So here I'm on my VPC console. So first we need to enable our flow logs for our VPC. By default, flow logs will be disabled, and we need to enable those manually. So select your VPC and then go to Flow Logs tab and then click on Create Flow Log. First, we need to select the filter. We can either select accept, reject, or all from the drop down. So for this demo, I'll select all. Next, we need to specify a role with permissions to create log groups and streams on CloudWatch. So I already have a role created called as Flow Logs role. If you don't have a role, you can click on Setup Permissions link here, and you'll be taken to IAM console, where you can create a new IAM role. If we have a look at the permissions, so we need to provide create log group, create log stream, describe log groups and streams, and put log events. I'm canceling this as I already have the role created. So this is my role, which is called as Flow Logs role. And finally, we need to provide a name for our log group on CloudWatch. So I'll call my group as say VPC Flow Logs, and then click on Create Flow Log. So now all our VPC logs will be shipped to CloudWatch. I'll pause my video here and I'll access my instances in the VPC just to generate some logs. I'll give it like 5 minutes for the logs to appear in CloudWatch. Now let's head to Elasticsearch console and create a cluster for our Elasticsearch. So I'm on my Elasticsearch console. I don't have any Elasticsearch domains as of now. So I'll create one by clicking on create new domain. So I'll just call my domain as VPC Flow Logs, and I'll select the latest version of Elasticsearch, which is 6.2, and then click next. Next, we need to configure our cluster. So for this demo, I'll just use one instance, but for production workloads, you might need to use more instances based on your data. For instance type, I'll go with T2 medium, which is sufficient for this demo, but again choose right size for your production workloads. Next, we have dedicated master and zone awareness options, which I won't be using for this demo, but for your production environments, you might need to select these options for high availability and performance. Coming to storage, the storage type, I'll leave it as default, which is EBS volumes. And then the EBS volume type, I'll use SSD. You can use provisioned IOPS SSD or magnetic volume type. I'll go with general purpose SSD. And as far as volume is concerned, 10 GB is sufficient for this demo, but choose the right size depending on your data. And if you want to encrypt the data at rest, you can enable it using this checkbox, enable encryption at rest. And Elasticsearch automatically takes snapshot of your volume once a day. So you can specify at what time you want to take that snapshot. I'll leave the default value, which is midnight GMT, and then click next. For network configuration, we have two options. We can either use Elasticsearch instances within the VPC or in the public space. So obviously launching within VPC is more secure. So if you don't have a requirement to make it public, please select VPC access, which is recommended method. So for this demo, I'll just select public access. But if you select VPC, you need to select your VPC and then your subnet where you want your instances to be launched, and then the security groups. And you can restrict the permissions to your Elasticsearch domain using these security groups. So for this demo, I'll go with public access. So you don't need to specify any VPC in that case. Next, we can configure authentication for Cabana Web Console, and you can use Cognito for that. So if we enable it, we need to specify our Cognito user and identity pools. So if you don't have these pools, you can create them using these links here, create new user pool and create new identity pool. So I don't want any authentication for this demo, so I'll skip it. You can use your Cognito pools if you wish here. Next one is access policy. So this basically defines who will have access to your Elasticsearch domain. So this policy is similar to your IAM policies, so you can be as restrictive as possible. So even if you are creating your domain in public space, you can still restrict access to your domain and your Cabana Console using this access policy. So we can use inbuilt templates to create the policy, or we can write our own policy. So if you click on this select template, we have different options. So we can provide access to specific AWS accounts or IAM users, or we can restrict based on IPs, or we can deny access to the domain completely, or we can copy the access policy from another domain if we have it. And then you can allow open access to the domain, which is not recommended. For this demo, I'll go with access to the domain from specific IPs. So I'll just provide my IP there, and you will be asked to provide your IP. So I'll just paste in my IP here and then click OK. As you can see, it automatically generates your policy statement. So it is basically providing access if the IP address is equal to this IP address, and then the resource would be your ARN of your Elasticsearch domain. You can modify this policy and add more IPs or CIDR blocks to this particular policy. Once you're happy with the policy, we can click next, and we are on the review screen. You can review all the settings here and then click confirm. So this will create our domain. So this domain creation will take approximately 10 to 15 minutes to provision all the resources required. So I'll pause the video here and get back once it's created. Okay, the domain creation is now complete. So you should see the configuration status active. The searchable documents will be empty as of now, as we haven't started streaming our VPC logs to this domain. So if we click on the domain name, we should be seeing the URLs for our domain endpoint and Cabana. Now let's head to CloudWatch console and stream our VPC Flow Logs to this Elasticsearch domain. So I am on my CloudWatch console, and I can see my log group created, which is VPC Flow Logs. And I have a log stream for my network interface. Let's select the log group, and then from actions, select stream to Amazon Elasticsearch service. So as you can see, we can stream to a domain which is in another account as well. As we have the ES domain in the same account, I'll select the first option, and we should be able to see our domain in the drop down list, which is VPC Flow Logs. If we select another account, you will be asked to provide Elasticsearch ARN and endpoint URL. So you can find these details from our Elasticsearch console. So this is the ARN and this is our endpoint URL. So I'll select the first option, which is this account, and then I'll select my cluster name, which is VPC Flow Logs. As I said earlier in this video, a Lambda function will be created, which will be sending our VPC Flow Logs to Elasticsearch domain. So we need to provide a role for our Lambda function. So from the drop down, you can select create new role, and you'll be taken to IAM console where you can create a role. You can provide a role name here. I'll just leave the default, which is Lambda Elasticsearch execution. And if you view the policy statement, you can see that we have permissions for create log group, create log stream, put log events, and we have an additional statement for Elasticsearch HTTP post, and the resource as all Elasticsearch domains. You can provide your ARN of your domain if you want to restrict permissions for your particular Elasticsearch domain here. So I'll just leave the default policy statement and then click on allow. So we have our execution role selected here, which is Lambda Elasticsearch execution. So this particular role will be assigned to our Lambda function, which will be pushing the logs to Elasticsearch domain. So once the role is selected, click on next. Here we need to select the log format. So by default, we have VPC Flow Logs, CloudTrail, Lambda, common log format, space delimited format, JSON format, and your own custom format, which is other. So for this demo, obviously we'll be selecting VPC Flow Logs, and this is the format of our VPC Flow Log. So we can see our source and destination addresses, source port, destination port, and we have our protocol, packets, bytes, and so on. And we can test the pattern here, and we should be able to see the results. So it found 50 matches, so that means 50 events in the sample log file. So the pattern here is valid, so we can use this particular pattern. So once that is selected, click next. And this is the review screen. Verify all your settings here, and then click on next. And then start streaming. So this should start streaming our VPC Flow Logs to Elasticsearch. So give it a minute and we should be able to see the stream on our Cabana console. So meanwhile, let's have a look at our Lambda function which got created. So I'll go to my Lambda console. So this is the function which got created automatically, just called as logs to Elasticsearch, and then your Elasticsearch domain name, which is VPC Flow Logs, and it by default uses Node.js runtime for our function. So if you go into the function, you should be able to see the code for our function. So this is the endpoint URL, which is nothing but our endpoint URL of our Elasticsearch domain. So this function receives the input logs, that is VPC Flow Logs in zipped format. So this function will basically unzip it, and it does some transformation and push the logs to Elasticsearch. So if you scroll down a bit, we have a function called as transform, which basically transforms our payload. So if you observe the code here, it is creating an index with a prefix of CWL hyphen and then your timestamp. So indexes are the way we identify and categorize our logs or data in Elasticsearch domain. So we'll be using this prefix in our Cabana Console in a moment. And these are the fields we'll see in our Elasticsearch domain for this particular VPC Flow Log. And the post will happen in a function called as post, which is this one. So this function basically pushes the log to your Elasticsearch domain. So you can modify this function and change the indexes and fields as per your requirement, but the default function will serve most of the use cases, and you can use this function as is without any modifications. Now let's go to our Cabana console. You can find the URL on our Elasticsearch console. So this is our Cabana's home page. So go to discover. By default in a fresh Elasticsearch domain, we don't have any indexes created. So we need to create an index pattern to identify the data in our domain. So from our Lambda function, we know that the index pattern prefix is CWL. So I'll use the same CWL hyphen star. You can use wild characters in the index pattern and then click on next. So here we need to select the time filter field. So if your logs does not have the timestamp, you can skip this. So for this demo, I'll select timestamp as my flow logs do have timestamp. So select that and then click on create index pattern. So our index pattern is now created, which is CWL hyphen star, and you will see all the fields and their data types. So all these fields are now available to visualize and query our data. So as you can see, we have our action, we have our destination address, we have our destination port, and then we have our source address and a source port. So we'll use these fields to create visualizations and dashboards. So let's go to the discover section again to check our data. As you can see, we have our data populated already, and we have around 69 hits. So for this demo, this number is too low, but for production workloads, this number will be in hundreds of thousands of hits. You can see a graphical representation of the count of entries in the log group based on timestamp here. And below you can see the data for each entry. So let's expand one entry here, and we can see the values of all the fields. So you can see the data either in a tabular format as we are seeing here, or you can see it in a JSON format. As you can see, we have our source address, destination port, destination address, action, and so on. Now let's use this data and create some visualizations. So click on visualize section here, and I don't have any visualizations as of now. Let's create one. So click on create visualization. So first we need to select the type of visualization, and we have almost all major types available here, like line charts, pie charts, bar charts, data tables, gauges, maps, and so on. Let's first create a pie chart for our say action field. So I'll click on pie chart here, and here we need to select the index pattern we wish to use for our chart. So I'll select the pattern we created, which is CWL hyphen star. And by default, it will give you a chart based on count. So let's customize this chart. So on the left hand side, you can see two sections here, metrics and buckets. So metrics specify how you want to aggregate your data. It can be based on count or sum, top hit, or unique count. So I'll leave it as count for this demo, as we want to know the count of accepts and rejects for this pie chart. So the next section is buckets. Bucket defines the actual data field that should be considered for this particular chart. So by default, we don't have any bucket. Let's create one by clicking on split slices, as we want two slices, one for accept and one for reject. So first we need to select how we want to aggregate the data in our bucket. So in our case, we want to aggregate based on action field. So the option for that here is terms. Terms are nothing but fields in the Cabana console. So I'll select terms here, and it will ask you the field name. From the drop down, I'll select action. I'll search for action and select action dot keyword. You can select the order as well here. I'll leave it as count. You can either define a custom metric or order it based on another term. And we can select the order, either descending or ascending. I'll leave it as the default value. And then the size. The size is nothing but the number of top values you want to consider for this field. So we know that we'll have only two values for this field, which are accept or reject. So we can say the size of 2, or we can leave it as 5. It should basically be equal to or greater than the number of values you want to consider for this particular field. Next, we can group other values if you wish to. This means that if the number of values of this particular field are greater than the size you provide here, it will group them as others, and you can include missing or empty values as well using these two checkboxes. And finally, we can provide a custom label. I'll just call it as action. So we can click on this little play icon here to update the chart with the data we provided. As you can see, we now have two slices, one for accept and one for reject. You can see the legend here on top right corner. And we can see the percentage and the count when we hover on the slices. So the accept count is 34, that is 66.67%, and the reject count is 17, that is 33.33%. We can add additional buckets if we want here. Say for example, we want to know the accepted and rejected ports in the same chat. So we can add another bucket. So click on add sub buckets and then click on split slices. And aggregation, again I'll select terms, and the field I'll select say destination port, which is DST port, and I'll leave all other values as default. And for label, I'll just say DST port, and then click on this play icon, and we can see the preview of accepted and rejected ports. So these two outer and inner chats are kind of in sync. So all the slices corresponding to the accept will have the accepted ports, and all the slices corresponding to the reject will have the rejected ports. So if you hover on this one, this is the accepted port, which is port 80, and then this one is port 123, port 22, port 48336, and then 48338, and these are the rejected ports, and we have 990, 80, 23, and so on. And the legend also gets updated based on your data. So that is how you add your fields to your chats. So let's save this chart. Click on save link here. I'll call it as accept reject ports, and then click on save. Let's add one more chat. So let's go back to visualize, and we can see our chart created here. Click on the add icon. Say this time we want to know the count of requests at a specific time. Let's represent that using a line chart. So I'll select line chart here, and then my index pattern, which is CWL-*. So here you see different options for metrics and buckets. So the metric, I'll leave it as count, which will be on the y-axis. You can see the count here. For x-axis, I'll select a date histogram, which is nothing but your timestamp, and then the field will be timestamp, and the interval I'll leave it as auto. For label, I'll say request count maybe, and then save. So as you can see, we have our line chart, which shows the count of logs based on time. You can hover on the graph to see the value. Let me make these lines smooth. We can go to metrics and access tab here, and then from line mode you can select as smooth, and then save it. It looks a little better now. You can change other settings as per your requirements. Let's go back to our data tab. Like we did for our pie chart, we can add additional buckets as well. So let's add another bucket. click on add sub bucket, and then click on split series. So we can split this count into different series. So let's say we wanted to split this count based on action, that is accept or reject. So select split series here, and then from aggregation drop down select terms, and then the field would be again action, and then leave all the other values as default. I'll just say action type maybe for custom label, and then save it. So now you can see two graphs, one for accept, that is green, and the purple one is for reject. So let's save this chart as well. I'll call it as request count, and then save. So now if you go back to visualize, we have our two visualizations created. Now we can create dashboards based on these visualizations. So let's go to dashboard. We don't have any dashboards as of now. So let's create one by clicking on create dashboard. So dashboards are made up of visualizations. So let's add our two visualizations to this dashboard. So click on add button here, and it will give you the list of all your visualizations you created. So I'll select both of them. Let me close this. So you can add as many visualizations as you want for this particular dashboard based on your requirements. And all the items will be in sync on this particular dashboard. Say from the pie chart, if you select accepted requests, you can see our line chart is also updated, and it will show only accepted requests. And here on the top, you can see the filter, which is action.keyword is equal to accept. So if you delete this filter, we can see all the requests, both accept and reject. So if you click on reject, you can see only the rejected graph. So by now you can imagine how useful these visualizations and dashboards will be if you have like millions of lines of entries to analyze. So for this demo, we only have less than 100 lines of logs to analyze or visualize. But for your production workloads, you can have, thousands and thousands of lines to analyze. And these dashboards and visualizations can give, more meaningful insights of your VPC flow logs. So you can save these dashboards as well. So you can click on save link here. I'll just call it as my custom dashboard, and then click on save. And this dashboard will be saved, and you can come back to this dashboard anytime. So if you go to your dashboard section, you can see your custom dashboard here. So you can create as many dashboards as you want depending on your requirements. And if you click on that dashboard, you'll get the latest data based on your time. So that is how you can visualize your VPC logs using Elastic Search and Kibana. Hope you found the video useful. If you did, please hit that like button and share it with interested parties. So that's it for this video. Have a good day, and see you in the next one.